Hello everyone, hoping that you're good. I've got with me another repair. This time we're working on a PlayStation 4 Slim. So there is no power, nothing whatsoever. I've already tested the console, nothing. I haven't tested the console with another power supply because I don't have now. But yeah, this is the customer power supply. Yeah, I've already blown the console out on the electronic vacuum there because it was filled with roaches. Just something else. I think you can still see some marks on it. It's pretty clean actually, but from the inside you can see them. Anyways, I've got it plugged in here to the AC supply, and just checking here, we do not have any ground. So we know very well that this is ground. And when we check on our 5-volt pin, that I'm not blocking it. I'm not plugging the multimeter there. I've got 0 volts. So we have nothing here. No activity. This power supply is not producing for us the voltage we expect. So we're going to go to AC just to make sure that our cable is working, and you can see it's bringing in 234 volts. So we have AC coming in, but we do not have DC coming out. So just to verify that one more time, ground, go back to DC, we have nothing at all, because I'm pretty sure you know some power supplies, like once the 12-volt line is now failing, it will still be able to produce 5 volts, but when you try to switch on the machine, it shuts off everything. So that's why I took off the AC, just to give the power supply a reset. So this I don't think has been opened before. It looks too clean. Actually, it has never been opened before. It's the original console from Sony, because I'm the one who took the sticker off from the console. Console had never been opened before. Probably for a hard drive change, that's possible, but the rest of the console, no, nothing. Okay, so here we are. I already know that the rectifier works. The reservoirs are getting charged. Reason being, when I was opening it up, it just saved me for a minute there. So yeah, I already know that it works. But just for you guys to know, measure up on our reservoir caps. We should be getting around 300, almost 320 volts. There we go. That's discharged. And now we are down to like 73. Let's empty it. Now it's empty. So now I can safely handle the power supply without any fears. Okay, as you know, our first suspect is always gonna be the fusible resistor. This guy over here, R1. So we'll go into continuity mode, check if our fusible resistor is still working. And our fusible resistor is working. I almost sprang for joy. If it wasn't working, I was gonna be very happy. Because it would mean we probably have got dead MOSFETs. But since it's working, it means we probably have a dead DNP or the DDA. In this case, it's what DAP046, which produces our 5-volt. But I think we kind of have some smoke. I'm not sure if it's visible for you guys, but look at our DAP049. Do you see the mark of somewhat like smoke on it? Yeah, there's a little smudge there, like something exploded over there. Anyways, that could be our problem. Let us check the MOSFETs. Our MOSFETs seem to be fine. The diode It's okay, these are obviously fine, they never fail. I've never seen them fail. And this usually does fail, this diode over here. In this particular case it's okay, and this has never failed on me, and it's okay. Let's check the Z now over here. Got like 1 ohm. That's okay. I don't believe there's a fault there. That seems to be okay. Got 136 and rising, that seems fine. Just checking some caps around. Alright, everything seems to be okay. Let's just probe around our DAP. And see if it's affected. I don't think it is, because we only have, now we've got 9 ohms here. I don't believe we should be getting 9 volts over here. 9 ohm resistance over here, like 10 ohms. I believe this is supposed to only have 1 ground. Let me grab another power supply just for reference. Alright, I've got a donor power supply here with me, but it still does have the 5 volt chip. So when we do the measurement again, you can see this is all okay. That's our ground giving us 0 ohms there. And when we measure this side, we've got like 14 ohms, 15. I don't know where that resistance came from, because when I measured at first it didn't. But you can see it's actually rising in resistance. So probably the caps are charging up. Yeah, the caps are definitely charging up. You can see it's rising faster now. And it's silent. And it's completely silent. So we do not have a short there. That's our ground. And that's okay. However, when we measure this one, I didn't keep it on for long, so I'm not sure if we've got the same condition. Ground. And now it doesn't buzz. All of a sudden it's fine. Alright, cool. So let's focus on our primary chip here, which we can clearly see had some explosive activity around it. I'm only getting 1 ground pin on it, so I don't think we've got an issue over there. I don't think we've got an issue either here. So where is our problem? As we say in our local language, is pinking. Let me check this one. Okay, that's 0 ohms. That's okay. Okay, so it seems like the chips are fine, or at least they are lying to me that they are fine. So if they are fine, who is the culprit? I have no idea. I am gonna work on guesswork on this, just based on the experience. But what I'm gonna do for now is I'm gonna plug the power supply in and hope that it doesn't zap me for some reason whatsoever. Just try to do some measurements, see if our chip here, if our guy is getting its voltage. See if it's getting the good stuff. So it is getting like that's 11 volts. No, this chip is supposed to be getting a lot of voltage. There, 218 volts. So it is getting the 218 volts. And you can see there's a 5 volt output on it. And that is our ground. So we've got a 5 volt output over here. Checking this side, we've still got 0 volts. Yep, we still have 0 volts over here. This side should be getting that good 3 something volts. And we're not getting anything on here. So this all seems to be fine. Okay, I'm gonna need something to drain this thing safely now. Because it's not really wise. Like, you won't die from doing it, but it's not wise to do what I do there. Alright, so I've got this multimeter from Real Life. It's a digital multimeter, so it's AC powered. Usually when I want to drain these caps, I'll just plug in nice multimeter, a nice soldering iron. So that's my negative over there, and that's my positive. As you can see, it powers on, and then until it drains out. So now it's off, which means these are empty. Simple. So you could use your own. Other people, they've got what are called dummy loads. So those, they work fine. You can see now I've got like 2 volts. There's nothing else left in it. Some people, they use dummy loads. So yeah, and for some, they will just use anything, man. Even a lamp, like a light bulb. You could use that. Just anything that's gonna use up the power. So I'm gonna start with this diode over here. This, these resistors, I know they're supposed to produce some resistance which is almost 1 ohm. So I am getting 1 ohm, but I want to see if I'm getting that 1 ohm from the resistors or from the Zener, because if the Zener is also fading, the 5 volts won't be produced. So we just want to verify that. So I've lifted the Zener. It is out of position now. Let us measure. I know we're still gonna get that buzz because these resistors have got very low resistance. Now we've got 2 ohms. So let me measure that Zener independent of the resistors, and it seems to be fine. The Zener is okay. That is not our problem, as I would have expected in general. Honestly speaking, I'm not so sure here. I pretty much have no idea. I have no idea. Like I said, I'll go on guesswork. So I'll start with this guy. So let me check on my power supplies if I've got one. I already have that one over there, and I have no idea if it works. That's another problem. I believe I've got a power supply which I worked on, and it starts from 5 volts. I don't think it produces 12, but 5 volts is produced. So let me check that where it is somewhere in the workshop, and I'll do a comparison with that before I start plugging components off. Oh, alright guys, so I have found another one. Okay, I'm just making sure it's recording. I found another power supply and 2 other donor power supplies. The particular power supply I'm looking for, I cannot see it. I would have to check on the other guy's desk. Probably it's on one of the tables, but yeah, that's too far. Anyways, this has got pretty much the same condition as the one we are working on, and they are the same power supply. ATP 160 FR, ATP 160 ER, but they are pretty much the same. Yeah, just the same thing, I guess. I don't know where the difference is, but anyways, this particular one, I didn't test to see what voltages I'm getting, but I could clearly see where we've got an issue. So here we've got some signs that it was bent. So you can see over there, bent through the motherboard. And then these four actually, they are gone. So when we measure across these two, because you can see the two pins are connected together and the two pins are connected together, same with here and same with here. When we're measuring across those two, we are getting 1.7 kilo ohms on the other power supply. So let's do just that in resistance mode. I'm pretty sure you can see that we've got 1.7 kilo ohms there. But when we're measuring here, we've got 3.56 mega ohms. That's an M there. Is that even visible? I believe it was. There you can see it's in mega ohms, that's in kilo ohms. So when we grab another power supply, just to verify that, what do we have? We've got 1.6 kilo ohms. 1.6 kilo ohms. We've got 1.6, 1.6. But on this particular one, we've got 1.7 and 3 mega ohms. Anyways, I'm going to plug it in just to see what we're getting with this. Are we getting 5 volts or not? Alright, power supply is on. Let's just check if our big caps are being charged. So multimeter over there. Yeah, the big caps are charged. So are we getting our 5 volts? Where is ground? Ground is over there. We're getting 0 volts. So pretty much I've got the same problem, no 5 volts. And when we measure over here, our 327 volts is getting here. No output on the diode. And our 5 volt chip, it's getting 7.87 volts, which is wrong. It's supposed to be getting 200 and something volts, and it's getting 7 volts. And the output becomes what? 0 volts. It still produces 5 volts for some reason. So I'm not sure that 5 volts comes out or it's going in. But yeah, we pretty much have got 7 volts coming into this chip instead of the desired 200 and something volts. So let's change those resistors over there. But when we're looking at it, we've got 200 volts coming here, but we do not have 200 volts going out to get to this chip. The only reason why you would get a resistor pin like this is because something is wrong ahead. Something has to be wrong up ahead. So it could be either a cockroach died here, where there's a pen mark, causing the circuit to have a surge going back and blowing up these two resistors. That's one possibility. Or the second possibility, this got fried. This is dead, and it has caused the resistors to fail. So there's only one way to find out, make it fail again. So I'm gonna just change the resistors, and then we will see from there. What time is it now? It's 3:07 a.m. I still need to sleep, but yeah, I'll have a lot of sleep tomorrow during the day or whatever. So I've taken even the ones that were giving us 1.7 volt ohms. Reason being, we got 1.6 from the other power supply, so I'm not gonna trust 1.7. There are times when these things are very particular, especially if it's a Hall sensor. Yeah, a Hall sensor is a no-nonsense thing. Doesn't tolerate anything. Let me just measure to see if we've got the same size. So we've got 1.6 and we've got 1.6. So we can grab these 4 and replace them on our power supply that we're going to be working on. So you can see this is not the same power supply that we were working on at first. And now we're working on 2 power supplies, but this is none of those 2. This is just a donor board. It's got parts missing all over. So not too stressed about that. There's a reason why I'm not using hot air, and I'm pretty sure you already know why. And these motherboards, they love to be like popcorns. You apply them, you expose them to heat for a long time. Not even for a long time, I mean, it's a matter of seconds, like 10 seconds. It will start bubbling up. And that will complicate your life. You can probably still fix the board and have it work, but yeah, at that point it's already complicated. So you have to use the hot air only if it's necessary, and it would be wise to first like add solder to all the pins of the chip that you're removing, especially these. First add solder so that when you're now coming with hot air, you don't spend much time on the area. So this is, yeah, that's pretty much it. I don't even know why I'm using my left hand for this. I guess both of these 2 tasks, they need you to use your strong hand, grabbing the component and grabbing the soldering iron. So I guess that's why I'm kind of struggling to straighten and position the resistor. But anyways, that's in place. You don't want it to be really straight like a military cop. You just want it connected. The rest is drama. Okay, here's number 3. And number 4. Hoping that you can see, but I don't think that's really necessary for me to be up close and personal with the resistors. You get the gist of the whole matter. Alright, these are in. So let's just measure our resistance once again. So now we've got 1.6 and 1.6 kilo ohms. There's no mega ohms anymore. The one thing that I'm going to do though is check if any of these caps has got a short, because I can see that there has been some soldering work done here. I'm just hoping that we do not have a problem where the resistors explode again. This all looks to be fine. I did check these terminals though, these pins. So this is the one that gets to rise and rise and rise and rise when you come back. Ground. So yeah, it's rising now. So I wouldn't really worry about that because it's rising up. Yeah, and that's pretty much it. Guess I can test. I don't know. Wish me luck. First thing that I'll do is to remove my face. I still wanna look like a human being. Let's go voltage mode. We obviously have got our 300 volts here, DC. What are we now getting on the chip? Okay, 214 is now there. And Unfortunately, we still have got 0 volts here. So at this point, I'm gonna have a wild guess and say one of these two is dead. That's the whole reason why those blew up. So I'm gonna start with this one. He's closest to the danger, so I'll go for him. So at this point, we are pretty much the same condition as the other power supply. Yeah, just pretty much the same condition. So we'll work on both power supplies. So again, I will need my soldering iron so that I can discharge this guy. I do not want it discharging on me. That is not really gonna kill me instantly, but it is enough to cause some discomfort. Yeah, you will not enjoy it at all. So we wanna take off that guy. How do we do that? I do not have new ones anyways. So I have to take from donor boards, which I don't even know if they're working or not. Sucks to be me. Anyways, if I confirm that that's the issue, then I don't mind ordering chips. I always order chips. Alright, so the main issue with these components is that there's glue. There's glue underneath the chip. So once you remove it, you'll see there's a reddish glue that remains behind. So I have to try to be as quick as possible with this. Because I don't want to stay here for too long. There we go. That was pretty easy. So that is the one that gets to hold this guy in place. Let's refresh our pads there. 1, 2, 3, 4. Yeah, that's okay. So where are we gonna get the chip from? So far I've got 2 donor boards that I can get the chip from, and fingers crossed the chip works. Yo, you've lost focus, man. On this donor board, I don't really care about the board bubbling up. But anyways, I could give you a sample of how it looks when it has bubbled up. Let me do it over here. I guess that was the wrong spot because it's got a huge surface area there. Let me try it on this because it usually bubbles up on there. I'm gonna take this chip off anyways because you see that's a bubble. Ouch. It was out of focus. Anyways, the bubble looks like that. You can see I can flex it. Yeah, that's how it looks when it bubbles up. And as I was saying, I'm gonna take that chip off because I will probably need to use it anyways. So I'm thinking to myself, I could replace the smaller one on this power supply and the big one on the other power supply, and see which one gets fixed. Because this is a learning experience. I have not fixed this before. I've pretty much had a rough idea of how it works, and yeah, that's how I know like I'm supposed to get 200 volts there, this and that. Yeah, but I haven't really paid that much attention into the full details, like the way I can kind of explain laptops. I didn't do the same with this. Reason being, sometimes like it's kind of easy to just buy in another power supply and life goes on. but in this case it's number one, not easy to get a power supply, and the supplier pretty much has no stock, and number two, it would be cheaper on my expenses to get to fix the power supply myself. Okay, I don't think we've got any output yet. We have an output. We have an output, guys. We have an output. 4.7 volts, 4.7, 4.8. Yeah, I'm not sure. I'm not sure if this will affect us because I would pretty much prefer it to be 5 volts. But we do have an output. So our issue is been resolved. Okay, I don't know what I'm supposed to be getting on these two terminals over here. Whoop! I just blew it. Ouch! My tweezer, my what is it called? My probe. It came across the two terminals and the guy exploded. Huh. And as you can see, it did the same chain reaction which we just fixed a few seconds ago. It's blown. This is obviously dead because these have blown up. So let's just check. Going back, what resistance we've got here now. We still have got 1.6. Same with here, we still have 1.6. Where's our fusible resistor? Just want to see if it's working. Fusible resistor is over here. And fusible resistor is gone, it's blown. So yeah, since the fusible resistor is blown, we will now have to replace the fusible resistor, these four guys, this guy, and then this guy. So I'm not really going to bother with that at the moment. I will take the other power supply and replace the same chip that I just replaced right now, the DAP. It's the DAP 46046. I will replace that because this is the initial power supply that we were working on. Yikes, like I said, sucks to be me. So on this motherboard we're gonna fix it. It's the one that we want to work, so we do not want it to bubble up the way that donor board did. So I'll add solder to it. Solder and flux, that will kind of lower the melting temperatures around that chip. Alright, let's go. Alright, there goes our chip. So I have one more donor board, and this again I have no idea if the chip works or not. But anyways, I'm gonna pray that it does. I'm gonna pray that the chip does work. So this is the fourth board. So there are two donor boards and two that I wanted to fix. Alright, I didn't prep that area. You can see we've got a bridge over here. So it was just one silly mistake, and the whole thing is gone. Lucky enough, my face was far away. I don't even know where the piece of that diode went to. You know, that's the downside of this. Sometimes it can just come to your face. That has happened before. Oh, it was still hot. So let me just give it a shake. I'm gonna blow it so that it cools quick. Okay, my phone kind of went off. It was talking about temperature being too low. Anyways, I've replaced the chip, but I noticed something. There was a little bit of discoloration, so I measured this resistor. I'm getting something like 5 mega ohms, 6 mega ohms. Focus on the multimeter. Can I? The angle doesn't allow me to do that. Yes, now it will. Aibo. Don't be fancy. Anyways, we've got like 7 mega ohms on this resistor, and on the next one we've got 20 ohms. On this one we've got like 1.9 mega ohms, and on this one we've got like 1.3 mega ohms. So I cross-checked with my donor board just for, I don't know, just for reference. 1.6 mega ohms, that's okay. 1.9 mega ohms, that's okay. 148 ohms, that's not the same with that one. 19.9, that's the same. So this resistor, there's something off. I checked with the power supply which we just fixed and exploded. Yes, when we're fixing, there is no I, there's a we. We killed it together. I'm joking. That's the one that we had fixed and it went off. You can see we've got like 100 ohms, 100 kilo ohms there. Of course, this is now off. These are going to be okay because they're not discolored or anything. But you can see this is giving us 100 kilo ohms. And I'm going to confirm again with yet another donor board, the fourth board. I've got 147 ohms, kilo ohms. 147 ohms, I mean. So that's the resistance we're looking for, which means we have to change that resistor, not just the chip itself. So which could mean that the chip which was here on the second power supply, it could probably be fine. It could probably still be working. The only issue could have been this resistor here. Let's take that off. I'm gonna be tempted, really, if it works after changing these two, I'm gonna be tempted to remove the chip and put back the original one just to see if it works again and confirm if the issue was the resistor. But that's very tricky because yeah, at the end of the day I need to have a working power supply in the morning. So I'm not if it works like this, I'm not gonna experiment on this one. I'll probably use the chip on that power supply which we blew. Okay, there goes the resistor. I'm gonna add some solder to its terminals, to its pins, so that it makes a solid connection. I guess that's pretty much it. And that means I can probably test this power supply. So yeah, fingers crossed, let's have a look. And this time if it works, I'm not probing anywhere around the board. I'm going straight to the main voltages that we're looking for, which is 5 and 5. So ground pin, the 5 volt is supposed to be coming from over here. I do not see any of it. Yeah, it is working. It is working. 4.7, 4.7. So again, our issue was related to this area here. In this particular case, it could have been that resistor or it could have been the resistor and the chip, because those are the two things that we changed on this particular power supply. So that's it for now. I'm just gonna close this power supply up and test the console, see if it works. And if it works, that's it. I'm not experimenting on this power supply because I don't think I've got a lot of donor ports. I'm just gonna drain the power now before I put the power supply back into its chassis. There we go. There's something that I've been considering lately, which is to go back to my country. Yeah, I don't find this place fascinating anymore. It is beautiful, but yeah, it's got crime, like a very serious crime, deadly crime. Just last week, my mother witnessed someone getting shot. And as much as she was terrified, it has pretty much become a normal occurrence to her because of the area where she works. And yeah, and now I'm not really comfortable with that. So yeah, I've been considering having to go back. But then I don't know if there's a clientele for such a business where we come from. I know there is, but the numbers will probably be less than we are used to here. And most people would argue to say, why don't you change cities or this and that? But then that's the thing with South Africa, you're not safe in any city. Not at all. So we're gonna plug the power supply, guys. I'm expecting to hear that sound. I did not hear that. Let's go and test. So I always start with eject. Oh, we've got eject now. And we've got a fence pin. Power supply has been fixed. Let's check for display. Don't mind the lines. The monitor has got lines on it. Give us display. We still have got a blue light pulsating. So the machine is still doing storage checks. We've got a white light. There we go. Checking system storage. Do not turn off the PS4. When the check is complete, restart automatically. This is nice. This is beautiful. I could have 2 power supplies by now if I if I wasn't. Yeah. And just a thought, I didn't discharge this power supply when it blew up. Let me see. It was still loaded. I could have just landed my hand on it because it's just next to me there. It was gonna shock me. I just remembered now when I just saw it there. So this has been fixed, guys. This is working. We've got a white light. It's rebooting now. Blue light doing the checks and everything related. There we go. That's the PS logo. This is fixed. I'm waiting to see it get into the system and then I can end the video. Because I think we're now almost 40 minutes, something like that. Because this is now 2 videos since the phone had to stop recording the other time. But let's see. There we go. PS4 was not turned off properly. What? Pretty much the common statements of Sony. I'm gonna plug the controller that I use for testing, which is this EPECA controller. They make really good controllers, by the way. I've got 4 of these. 1 for PS, 1 for Xbox, and 2 for PC. There we go. Photosensitive epilepsy. Oh, is it epilepsy or something? Yeah, there we go. This is working. This is definitely working. Does it need a CD to play FIFA 22? It doesn't. This is good. Thanks for watching, guys. I will see you in another clip. Cheers and goodbye.